All right, what we're going to do is we're going to look at a question of what if I were to drop a ball, okay? So if I were to drop a ball and it then hits the ground. So let's say we drop it from, we're just making up numbers, 4 meters here, so it's 2 kilograms. And so it's still 2 kilograms. I don't know why I wrote that. And we said, hey, what's the velocity? So what we could do is we could say up here, it has gravitational energy. And down here, it has kinetic energy. And as it falls, this type of energy up here, mgh, converts into this type of energy. So if I know what the amount of energy I have up here, I could then set it equal if they're equal. Now, we're going to deal with a lot of situations where they're just going to be equal because we say ignoring friction, ignoring air resistance. So I could say that the energy at the top, gravitational energy, turns into kinetic energy at the bottom. So gravitational energy is mgh, and kinetic energy is 1/2 mv squared. So I could plug in my mass. G, we're just going to make it 10. Okay. Height, 4 meters. So it's going to change 4 meters, 1/2 mv squared. So is that 2880 equals v squared? So you get a v of like 8.9 meters per second. Okay, let's talk about how this is useful. Let's say I had a different problem. I'm like, well, I've got this ball, but it's on a pendulum and it swings. How fast is it going at the bottom? Oh, I don't know how to do that. What you do is you say, what's the starting height? What's the ending height? How far did it fall? Well, let's say it was a 2 kilogram ball. It is a 2 kilogram ball. And it started at a height and it ended at a height, but the difference of the height is 4 meters. If that was my situation, see how this is 4 meters? See how this is 4 meters? If they both start from rest, we're going to have both with the same ending velocity. So on the activity dealing with the roller coaster, okay, it starts at the top and it just has gravitational. I believe it's not moving at the top. And at the bottom, it just has kinetic. There's not any height left. Okay. I want to do one more. So one of the things I've noticed is students will say, this equals this, and that's always true. Hold on, let's do a problem where it's not as simple, but it's not too bad. Okay, ready? We're going to take a ball. We're going to chuck it off of this. Let's make it 5 meters tall. Let's make it 2 kilograms, and let's chuck it at 7 meters per second. Okay. Well, it goes woo, right, and it hits. Question is, how fast is it going when it hits the ground? Okay. Well, what we do is we say, well, what type of energy does it have at the start? And what type of energy does it have at the end? Okay. And if there's no air resistance or friction, we set them equal to each other. So the energy at the beginning, it's off the ground. It's going to go through a height. So we say it has gravitational energy. Is it also moving? It's doing both. And so it also has kinetic energy. And then as it falls, that gravitational energy gets converted into motion. And so right before it hits, it has more motion, more kinetic energy. Another way that I know some people, some different researchers have talked about this, I actually kind of like this one, is to say, hey, initial and final. So initial, I have some gravitational and I have some kinetic. And at the end, I don't have any gravitational, but I have a lot of kinetic. And as long as there's no friction, I can say that these are equal. Okay, so this would be gravitational energy plus kinetic gets converted into kinetic. These kinetics are not the same. If you look visually, they're different. When I've done this in class, instead of doing bar charts, we would actually think about energy in terms of, well, at the beginning, I have some type of energy, gravitational, I have some type of energy, kinetic, and as it goes down the ramp, now it's all kinetic, and it's all of them are that kinetic energy. And so we think about almost like these bar charts as little chunks of energy. And so if I start with, 4 or 3 or something, and then I think about my kinetic, when I combine them, at the end, I have that total. Where it gets tricky, and we're going to get to this later, is what happens if there's friction and it removes some energy. Then we got to get creative. And so we'll give you some strategies when we get to that. But we're not there yet. So on this problem, let's solve it out. So I got mgh plus 1/2 mv squared equals 1/2 mv squared. So this is mgh, 5 meters. It's going to change 5 meters, plus 1/2 mv squared. mv squared. Common mistake students will make, we will too probably, is where do I stick my velocities? So here, this is my initial energy, and this is my final. And so if I have my initial energy here, those are all the things at the start, and my final is all the stuff at the end. So it's a way to separate it out. So if you solve this out, you get 100 plus 49 equals v squared, because 1/2 times 2 is 1. So I get 149 equals v squared. So you get v is, I don't have a I do. So the velocity is square root of 149, square root 149, 12.2. Where's my pen? There it is, 12.2. And notice, it started at 7, and now we're going at 12.2. So it increased, it gained through that process. I want to do one more, not because I want to just have you do a whole bunch of work, but instead, this is this one gets people. So I've got a roller coaster, and then it comes here. So this is at 20 meters, and this is at 31 meters. Okay. And let's say when it was here, it was going 20 meters per second. And the question is, how fast is it going at the top? And they don't give you the mass. Okay, so what we do is you stop. You go, okay, what forms of energy do I have? Here I have gravitational. I'm off the ground. Plus, I also am moving, so I have kinetic. So that's my initial. What do I have at the end? I have gravitational energy. I'm off the ground, and I have kinetic. So I have mgh 20 plus 1/2 mv squared, 20 squared. mgh plus 1/2 mv squared. Notice how they didn't give you mass, but look at what happens. Since they all have an m involved, it cancels out. So now you have something that is a little more doable. So you got 10 times 20 plus 1/2 of 20 squared equals 10 times 31 plus 1/2 of v squared. Okay, so was that 200 plus 200 equals 310 plus 1/2 of v squared. 4 minus 3 times 90 is 1/2 v squared. So 180 equals v squared. So I get a v of square root of 180. Get 13.4. Now, you always have a checks and balance. You go, Shmear, is that right? Well, watch this. It started at 20, it went down, sped up, and then went up, slowed down. Is it going to be going slower because it's higher? Yes, 13.4. Okay, so just trying to give you an overview. Those are 3 problems to kind of get you going. So as you get into your pivots, right, they're not as this complex, but I wanted to give you an idea of kind of where we're going with this. So, hey, jump in. You got this.